Lesson 1, Types of Set and Set Notation. So a set is a group of objects. It can be any group of objects. And an element is the object that is part of the set. So we often put them in these oval shapes, and that is a type of notation to show that it is a set. It is a group of objects. So for the first example, we have fruit. Fruit is the set. And elements of the set would be anything that is a fruit. For instance, apple, cherry, grape, banana, peach, star fruit, whatever you really want to put. All of those things would be an element. And because we know that there are more fruit than just these three, we can put a dot, dot, dot. And what that means is that there is extra elements beyond what is listed. So we can write them inside of the oval, and that shows a set. Another way to show a set is set notation. So what we do for set notation is you take a capital that pertains to the set. For instance, W. F. I even wrote that. And we put it inside of the squiggly brackets. And there's actually no real word for squiggly brackets, so I'm just going to continue to call them squiggly brackets. And all we do is write them inside. So we have apple, cherry, grape, dot, dot, dot. And that is set notation. So for example 2, we have even numbers, and that is our set. And elements in that set would be 2, 4, 6, 8, and it goes on for infinity. So this dot, dot, dot really means and on for infinity. So our elements are 2, 4, 6, dot, dot, dot. Our set notation would be E for even is equal to 2, 4, 6, 8, dot, dot, dot. So that would be set notation. The last one has a little bit more restrictions on it. It says whole numbers between 1 and 20. So our set is whole numbers between 1 and 20. That's very shorthand. Our elements then would be every number between 1 and 20 that is a whole number. And what a whole number is it means that it's not a decimal. It can't be a fraction. It has to be whole without any decimal points. And it's positive. So that's what a whole number is. It also includes 0. And I have a list of the common sets on your page to show the difference between each of those. So just to go through them quickly, digits are 0 to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are all the digits. Think the digits on your phone. The set of whole numbers is 0 and up. The set of real numbers is anything. It can be a decimal, it can be a negative, it can be a positive, it just cannot be imaginary. And the natural numbers are, think of the numbers that you can count on your hand. So 1, 2, 3, 4, 5, and blah, 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 on and on and on. So really what it means is you can't have 0. Integers are positive and negative. Odds are 1, 3, 5, evens 2, 4, 6, and the prime numbers are numbers that can only be divided by itself and 1. So the whole numbers between 1 and 20 are actually all the numbers between 1 and 20. And the way that we can write this easier is once you've written at least 3 numbers, if you put a dot, 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 and then write the last couple numbers after it, I know, and everyone would know, that it means all of the numbers in between. So if you go 1, 2, 3, dot, 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 19 and 20, you can see that that's all the numbers between 1 and 20. But make sure you still write a couple here and a couple here, just to show the point. So we can write this in set notation as W is 1, 2, 3, dot, 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 19, 20. Okay, a subset is a set that is within another set. And a way that we can show this is we can do it with a picture. So if we have set A, and it has the numbers 1, 2, 3, 4, 5, 6 in it, and set B has 2, 4, 6. Because 2, 4, and 6 are all part of set A, we know that it is a subset because all of them can be written within set A. So we could write set B as its own circle but inside of A because it's in both A and B. So 2 and 4 and 6 could go in here, and 1 and 3 and 5 would go outside of set B. I'm just going to do that in a different color. So, because of this, we have a way to show this in set notation. And the way that we write a subset is a U that's to the side like this. And the way that it's read is, there's two ways we could write this. We could put A subset B or B subset A. And the way it is read is that B is a subset of A. So you want to write your subset here first. So the way that we showed that there's a subset for set A and set B is B sideways U A. When we have this little apostrophe right here, this is called prime. So what B prime means is it's a complement. And so the complement of something is everything that it's not. So think about if you have all of the numbers together, B would be everything that's in B, so 2, 4, and 6. And B prime is everything that's not in B, but is still part of the big set. So 1, 3, and 5. So the complement of B is B prime. When you add them together, they make a whole. So B prime is equal to 1, 3, and 5, and you would write it in the squiggly brackets. If we wanted to determine C, a subset of B that contains odd integers, we would be wanting to put a circle in here to put all of the odd numbers in it. So because 2, 4, and 6 are all even numbers, we actually have no numbers in set C. So C would be equal to the squiggly brackets. You can put nothing in it to show that there's no numbers, there's no elements in C, or you can put a 0 with a line through it. That also means that it's an empty subset. Okay, a disjoint set is two sets that have absolutely nothing in common. So for example A, a disjoint set, if we made A equal to 1, 2, and B equal to 3, 4, they have nothing in common. So we would call them disjoint because no elements repeat. So that's disjoint. If we wanted a finite set, that means that there's a finite amount of numbers. There's a certain amount of numbers and there's no more that can be possible. So the numbers 1 to 5 would be a set of finite numbers because your numbers could only be 1, 2, 3, 4, and 5. An infinite set is numbers that could go on and on forever, and we already saw something like that. So an example would be all the real numbers. So you could put R is equal to ... -1, 0, 1, ... So this shows it goes on and on in both directions. You can represent sets using Venn diagrams. So if you were to think of a set of numbers, we don't know what they are, we'll say that U is equal to the universal set. So it's all the numbers you have. So they all are contained within this box. They're the universal numbers. But inside the box, we have A. So because A is inside of U, A is a subset of U. We also have a subset of A, that is B. And because B is inside A, B is a subset of A, and you could also say that B is a subset of U. Another way that you could write this is B is a subset of A, which is a subset of U. This and this mean the same thing. And everything that is not within the circles, but is within U, would be A prime. Either it's A and it's inside the circle, or it's A prime and it's outside of the circle. And remember that these two are called complement sets. So you can use Venn diagrams to express any sets of numbers. Okay, so we want to express with a Venn diagram and with set notation the multiples of 5 and 10 from 1 to 500. And we also want to write any subsets, disjoint sets, or complementary sets we have. So if we are to write our square, we will call this S, all the numbers, set S. And S would be equal to 1, 2, 3, 4, all the way to 500. So any numbers between 1 and 500. And inside that set, we have multiples of 5s. So let's call this set F. So for set F, I don't know why I made that green. We've got 5, 10, 15, 495, 500. So those are all of the 5s between 1 and 500. And inside of F, we also have the 10s. Now because 10s are both a set of 5 and 10, it's a subset of F. So T would be equal to 10, 20, 30, 490, 500. And we know that T would go inside of F because the elements from T are repeated in F, but there's more elements in F that aren't in T. So there are our different elements, and we want to use set notation to show this. So while this is good, this isn't quite set notation. And that is because we want to show that it could be any number. And when we want it to be any number and it to be more general, we usually use an X, or a variable. So the way that we would show this in set notation is we want to say F such that F is equal to 5X. So what that means is it's equal to 5 times any number, so that you can show that it is a multiple of 5. But we want it to be between 1 and 500, so we write 1 is less than or equal to X and less than or equal to 500. And we can also add in that X is an element of the number set. 1 second. So this is how you would write the set of F, which is multiples of 5s, in set notation. The way that we would write T is very similar. It would be T such that T is equal to 10X, so 10 times a number. It's still between 1 and 500, and all this means right here is it's between 1 and 500. And X is an element of the numbers, and that's just showing that it's natural numbers, 1 and up. If we wanted to write our subsets in set notation, we know that F is a subset of S. We know that T is a subset of F, which is a subset of S. We know that F prime is the complement of F. So that would be any number that's not a multiple of 5, like 2, 3, 4, 6, 7, 8, and on and on. You rescue homeless animals and you advertise on a website. You currently have dogs, cats, rabbits, ferrets, parrots, lovebirds, macaws, iguanas, and snakes. And to make this easier, we are going to just refer to them as D, C, but let's do lowercase. D, C, R, F, P, L, M, I, S. So we want to design a way to organize the animals on a web page, and we're going to use set notation and a Venn diagram. So the ways that we're going to set it is that A is going to be all the animals. We're going to separate it by warm-blooded and cold-blooded. And also if it's a mammal or a bird. So if we were to write this as a Venn diagram, we would have warm-blooded and cold-blooded. They're two just disjoint sets. They are two separate things from each other. So A, W, and C. Now mammals and birds are both warm-blooded, so they will both go in here. So M and birds. So that is what our set would look like. Now we need to place each of the animals into a place. So dogs is a warm-blooded mammal. Cats is a warm-blooded mammal. A rabbit is a warm-blooded mammal. A ferret is a warm-blooded mammal. A parrot is a bird. And so is a macaw and a lovebird. And iguanas and snakes are reptiles, so they are cold-blooded, so they go in this section. So there's our Venn diagram. Now we want to write that in set notation. So all in the squiggly brackets, we would just write all of the animals. So D, C, R, F, P, L, M, I, and S. Warm-blooded would be everything in that whole circle. So D, C, R, F, P, L, and M. So it's both the mammals and the birds. Cold-blooded is just the iguanas and the snakes. I've ran out of room. Mammals would be equal to D, C, R, and F. And birds would be equal to P, L, and M. And now we want to name all the subsets, disjoint sets, and complementary sets. So first we'll say all the disjoint sets because it's quite easy. So disjoints is where there's absolutely nothing that could overlap between the two. So we know that W and C are disjoint. We also know that mammals are disjoint from the birds, and that mammals are also disjoint from cold-blooded animals, and that birds are disjoint from cold-blooded animals. That now leaves us with our subsets. So we know that there's a subset from W to all the animals, and from C to all the animals. My subset starts to look like a C, so just be careful. So W is a subset of A and C is a subset of A. We also know that M is a subset of W, which is a subset of A, and we know that B is a subset of W, which is a subset of A. So there is all of our subsets. Our complementary sets is that W prime would be equal to W, and we also know that W prime is equal to C. Except I wrote that very funny. But because W prime and C are the same thing, we know that this is complementary to W. So the complement of W is C. C prime is the same as W, so everything that's not in C is in W. So the complement of C is W. And it can go the same with B and M as well. So B prime is equal to M, which is the complement of B, and M prime is equal to B, which is the complement of M. So they're all the opposite of each other. If we wanted to create a subset of fur-bearing animals, we would write it in set notation as well. So let's let F equal fur-bearing animals. So that would be the same as the dog, the cat, the rabbit, and the ferret. And so because it's the same as mammals for this instance, we know that F is equal to M for our example. But if we were to consider all mammals in the world, not all mammals have fur. So it's not always an equal set. It would be a subset. So F could also be called a subset of M. F would be a subset of W, so we could write F is a subset of M, which is a subset of W, which is a subset of all the animals. So there's our subset.